Hi everybody, Adam with FANUC here. Recently did a video on user frames, but want to take a moment to talk to you guys today about tool frames. So as we discussed, a user frame is a plane in space with an origin, an X direction, Y direction, defining a workspace. But today we're going to talk about the user tool, which defines a point of rotation and a point of your Cartesian coordinates relative to your user frame for where that tool is. If I zoom out a little, you can see RoboGuide tries to put a little orb at the default location. As I zoom in, you can see that there's a little green orb at what the robot's default user frame is. You might also hear us call a tool center point, TCP. It's synonymous. TCP, user tool, tool center point, it's all the same thing. But what it is it's a point of interest of the center of the tool that'll be moving around. By default on a FANUC robot, that TCP is right at the center of J6, or if you have a 5-axis or a 4-axis, it'll be the last axis of the robot. So what we want to do is we want to tell the robot where the tooling really is, okay? So in this particular example, I have an offset vacuum, non-axial with J6. We need to teach the robot where that is. So let's go through that. If you're not familiar, menu, setup, frames, and then right now my screen is already at tool frame, but if it's not there, if you see something else, just click other and go to tool. So let's dive on in. First thing I want to do is I want to give this guy a name. Let's name it vacuum. Now you'll see that by default, I can just type in where that is. Okay, that we call it direct entry. So I can say how far out in X, how far down in Z, how far left and right in Y. I can tell the robot where that suction cup is. So if you've got, quick tape measurement, or you got some SolidWorks CAD data, you can type it in and probably get really, really close. But FANUC makes it even easier than that. The robot can figure it out for you by going to your method, and for here and now, we're just going to focus on the 3-point. We can do another video later that discusses all the different ways of teaching your tool, but for the most part, most of your work, pretty much everything you're going to need to do is going to be surrounded about the 3-point. So you'll see that it brings up 3 different approach points. I'm going to show you what those are for the best, most accurate data you can get. So here's what we need to do. You need to jog your robot in world. Let's toggle this coordinate thing, right? We have joint, we have world, tool, user. Make sure you are in world so that you have your nice right-hand rule, X, Y, Z, Cartesian movements. And the other thing you need some point of reference. Very simple, okay? In this example here in RoboGuide, I've got a nice little pointer sitting on a table. This can be something that you have machined. It can be an existing feature in your work cell. Goodness, it could be a pencil duct taped to the table. It can be that informal. Just anything that is fixed and stationary for the 5 minutes it's going to take you to set it up. But the better of a point you have, the more accurate your data will be, especially if your tool has some kind of point, which this one does not. It's a vacuum, but we'll get to that. But you need some point of reference that we're going to dance around. So here we go. The first thing I need to do, and I'm gonna cheat a little because I have RoboGuide, which makes my life way easier. But you guys are going to use your directional keys, X, Y, Z. I'm going to click and drag because I can. And I'm going to take and I'm going to bring that suction cup. I'm going to bring that suction cup right down to that pointer. Okay, so let's get this right about here. And then what I want to do is I want to get the center line of the suction cup aligned with the center line of my pointer. So far, so good. Let's go to a front view. You'll be walking around and doing this a little bit yourself too. So front view, if I move this around, I want to get my center line pretty darn close. I'm a little off, but for demonstration purposes, here we go. So here's our first approach point. The center of my suction cup is at the center of this pointer. There's a nice little 360 sweep. I go to my approach point and I do a shift record. Perfect. Next, let's take your robot, move it up slightly so that you don't crash into anything. And let's just swing your tooling 180 degrees around if you can, okay? Always watch your cables, your lines, your tooling. You don't want to be crashing this thing. But really what you want to do is you want your second approach point to be 180 degrees out of your first one. So let me get it around there. That's pretty darn close. And again, I can cheat. I have RoboGuide, but something like this. Perfect. Okay. So now I've got this. I'm going to go back. I'm going to toggle back into world, and I'm going to bring that robot out, and we're going to do the same thing again. Okay. We're going to just reposition it to where it was, with that pointer lined up to the center line of the tool. Here we go. Get it about there. Get my Z back to where it's just about touching. Perfect. Let's go to my front view. Let's get this guy over. And it's not mission critical that it's 180 degrees. Do what you can. Greater than 90 is ideal. 180 is perfect, but something like this. So I'm going to give you a nice little 360 sweep again. You can see where that robot is now for my second point. Okay. And shift and record. Very good. Now, I want to go back to my original point. I can actually use the FANUC move to function and let the robot go back to that first point. Again, make sure you're not crashing or winding up wires, or make sure you don't knock over your tooling while you're doing that, or just manually jog it. Doesn't matter. But now what I want to do is I want to tilt this robot either yaw or pitch, which on your screen is either going to be the rotation around the X or it's going to be the rotation around the Y. Pick whichever one you prefer based on not hitting things and crashing or whatever. For this one, I'm going to go ahead and do my yaw, which is rotating the robot about the X. So you can see that I rotated the robot. If I were to use this key, you'll see that I'm rotating around the X-axis point. Doesn't matter. It's arbitrary. In a perfect world, I get this guy to 90 degrees. Okay, so that way we're from the top, we do a 0, a 180, and now we're doing a 90. But guess what? I can't do a 90 in this particular situation, auto backup time, because as I try to approach my pointer, I would knock it over, right? As I try to get that lined up, wham, you'd see there's some interference, and that is no good. Okay, so you're going to probably run into that in real life. So if you can't get it to be 90 degrees, do your best. Okay, get it to 80 or 60, 45, something. So I'm going to approach this guy in, again, such that the center, let me get on a side view here, such that the center of the cup is aligned with the center of my pointer, something like that. Get it down here, and let's look at my front view. Again, in RoboGuide, there might be some interference there, but Basically, I want the robot tilted and pointed at the center of that cup. Now watch what happens when we go to that third point and do a shift. Let me go to that. Shift record. There we go. We now have data. All of these jump from being recorded to being used. And we have data in the X, Y, and Z positions. And you can see that on my screen already, the little green orb jumped from being the default J6 position. It is now down here, right at the center of my suction cup. So if I take my robot and I go back to a home position, okay, now look where my triad is. Earlier in the video, you saw that the triad was up here in my J6. Now the triad is out here in space where the center of that tool is. And what's really nice about this is you now have control over the entire arm moving around that point. So test it. It's very important to test it. Take your robot and start doing some yaw, pitch, and roll. If you notice when I'm doing this, the robot holds still that point in space and dances around it. If you have a well-taught user frame, a well-taught TCP, you'll notice that as you dance the robot around, that suction cup stays perfectly in space and allows you to articulate around that point. I can even bring it down like this. I can tilt it sideways, and then I can rotate the robot around that. Oops, maybe a little better view here. Get back to my program. A little better view here if I swing around this way. You can see that the robot articulates all 6 axes while holding that point perfectly still. You'll find that that comes in very, very handy when teaching positions in space and having the robot behave around where that point of interest is. And now remember also, with that taught, anything you teach in your user frame, it's relative. Let's say I taught my user frame corner here. It's relative, where is the cup relative to my user frame corner? By default, the robot says, hey, where's J6 relative to my belly button, J1, J2? That's not always a good relationship to have, J6 relative to belly button. Who cares? But if I say, where's my suction cup relative to the corner of my table, now all of a sudden life gets really good. So please use these. Please take the time to set them up. They're very useful. If you ever change your tool, or even if you bump and bend your tool but don't have to necessarily replace it, you can retouch up those 3 approach points. Do your dance, 0, 180, 90. Do your little dance, and it'll update where your tool is now that it's bent, and all of your programs will go back to working perfectly, even with a bent tool, which is a good quick fix while maybe you make a new one or something. So, guys, thanks for tuning in. Please like and subscribe. If you need more information, feel free to contact us at 888-FANUC-US or on the web at fanucamerica.com, and have fun coding.